I think we can get started. I want to be conscious of everyone's time. Good morning, good afternoon, good evening. Thank you for joining us. My name is Brian Riggs. I am the administrator for ISAA, and I'm pleased to kick off today's very first Partner Spotlight series presented today by Croda. Today we're going to hear from Carlos Silva, from Croda Incotec as he leads a conversation about the opportunities and challenges associated with formulating microbial biopesticides, what you need to consider prior to formulating and producing such solutions. Carlos is a lead researcher at Incotec, where he has pursued his career over the last 10 years. He's based in Brazil, and his role involves studying the compatibility of different formulants with microorganisms, the application of biopesticides in seed treatment, and developing new formulations for biopesticide delivery. Carlos has studied in Brazil and holds a bachelor's degree and a license in biological sciences from Unipinhal, as well as a master's degree in plant protection from UNESP FCA. He's currently pursuing a PhD in agricultural microbiology. Carlos has a deep understanding of biological systems and combines this with practical skills in research and development to contribute significantly to Incotec's work program in advancing sustainable agricultural practices and policies. As I mentioned, this is our very first of many Partner Spotlight series. We're so grateful that Croda has agreed to be the inaugural presenter. We're very excited about today's presentation. If you are interested in becoming a partner and presenting, please feel free to contact any of the team members at ISAA, myself, Parker, or Lisa. I also want to let you know that if you have any questions throughout today's presentation, to please populate the Q&A bar. We will, at the end of the presentation, answer as many as possible. For those questions that we are unable to answer, we will have Carlos answer them and distribute a document following the presentation, inclusive of highlights from today. However, in order to receive that information, you will have to opt in at the end of the presentation. If you are unable to stay for the entire presentation, please email us and we'll opt you in. And finally, I just want to say thank you again to Carlos. I'll turn it over to you, my friend. And thank you everyone for being here today.
Okay, thank you, Brian. First of all, would you like to say thank you for all of you to attend this webinar. For me, it's a really nice opportunity to share what Croda is doing in this biological market. And of course, to say thank you for all the organizers for the invitation. First of all, would you like to share with all of you our proposal, that is smart science to improve lives. And we, as a Croda, we create, produce, and sell specialty chemistry to help our partners to create innovative solutions to some of the world's greatest challenges. And one of these world's greatest challenges is to create a more sustainable agriculture. And to do that, the biological products plays a really important role in this market. And to help our partners to activate these solutions, Croda is divided in three main sectors. The first one is the consumer care, where we are working directly in the developing of innovation delivery systems to provide a vital functionality to consumer care formulations, for example, sunscreens. Another important sector inside Croda is Croda Pharma, where we are working directly in the development of systems to deliver the active pharmaceutical ingredients and supporting our customers since from the beginning of the development program and helping them to create an innovative solution to this market. And of course, we have Croda Crop Care, that is the agribusiness division of Croda. And inside the Croda Crop Care, we have three different main companies here. The first one is Croda Crop Protection, where we are working in developing sustainable delivery systems for agrochemical ingredients and of course for biological ingredients. We have Incotec. Incotec is the company where I'm working today, and Incotec in the market is known as seed enhancement company. And Incotec is responsible to develop an innovative technology which allow us to apply the biologicals and the complex slurries in the seed treatment. And we have Plant Impact. And the Plant Impact is responsible to develop biostimulant chemistry to stimulate the natural plant mechanisms and improving the yield and the quality of these crops. And we are talking about to create a more sustainable agriculture. And the biological products plays an important role. It's an important tool in an integrated pest management program. We hear a lot from the market and sometimes from one of our partners that the biological products will replace the chemical products in the near future. But that's not true. The biological can be used together the chemical products. For example, using biological products, we can avoid, for example, an insect pest to get resistance from insecticide chemical molecule. And with that, we can using this molecule for a long period of time, for example. And because of that, biological is a really important tool in the integrated pest management. And also here is one of the most interesting parts of this market. This market is completely open for new technologies, for new innovations, and also it's open to improve the existing technologies. So this market is really open for new things, and this market can pay for it. Okay, Carlos, but what's the size of this market? What make this market really important for agriculture? Here I brought some numbers to illustrate how big is this market. Last year, the global market of biological products used specifically in agriculture reached $5.8 billion. And the forecast for 2030 is that the market will reach almost $18 billion. It's a huge market. And also, it's another important information that this market, the annual growth rate of this market is around 15%. So this market is open for new technologies, the market can pay for it, and the market is growing. Here, there's another interesting information. Last year, North America was the largest market in the world. And Asia Pacific will be the faster growing region between 2023 and 2030. There are some institutes where they mention that the Asia Pacific will pass North America in 2 or 3 years. But last year, North America is still the largest market in the world when we are talking about the biological products in agriculture. Another interesting information that in 2021, 43% of all biological products commercialized in the world was biofungicides. However, when we look more deep in this market, for example, for seed treatment, the bionematicide has the biggest share in this market. But here is the first challenge in this market. This market is really fragmented. For example, locally, we have, of course, the big players in the market, but we have the small players in the market, which shares a really important part of this market. And because of that, this market has this complexity. This market is really fragmented. Of course, the market can pay for new technologies. It's growing. It's nice. It can pay for all technologies we are trying to include in our formulations. But of course, this marketing has challenges. But for me personally, challenges means great opportunities. And the first challenges here is the shelf life. We are talking about a living organisms, and the shelf life is directly linked with the survival rates of these biological ingredients. And these two factors here is directly involved with the performance in the field. We have to create a formulation which allow us to create a product with a long shelf life that we keep the survival rates as high as we can, because the performance will be directly influenced by these two factors. Also, the environmental factors has a big impact in biological ingredients. If your biological active is sensible for any of the environmental factors, your formulation design must be considering to protect your biological ingredient from these external factors, because any influence can be impact in survival rates and consequently can impact in the performance of your product in the field. Also, our formulation must be designed to deliver a good distribution, because poor distribution means low performance in the field because of the characteristics of biological ingredients. For example, fungi conidius has a characteristic to be quite hydrophobic, and hydrophobic ingredients in application in the field can mean a poor distribution, and poor distribution will reflect in a bad performance in the field. And also we have to consider the application technology. Your product will be applied on seeds, or will be applied on furrow, or will be applied on leaves. Each technology requires a specific kind of formulation. But here in biological formulation development, we have to create a holistic vision. We have to consider all these aspects at the same time. Okay? So this also is really important. As I mentioned before, this market is really fragmented. We have a lot of players in this market, and we have to create a kind of differentiation of our product to enter in this market. And one way to do that is to know your active. You have to create a really deep knowledge about your active. And creating this information, you can create a chance to be different in the market. And the first reason is the same species, but different strain can report different performance. For example, we can use a bioinsecticide based on Bovaria, for example, and Bovaria strain 1 can control, for example, beetles in the field better than the strain 2. The same species, but different strains can report different performance. Also, the environment can affect the performance of your strain. For example, Bovaria strain 1 can control beetles at 25 degrees Celsius. But when the temperature reaches 35 degrees Celsius, for example, the control can cease. If your biological ingredient has this kind of characteristics, your formulation design must be designed to protect your biological ingredient against these environmental factors. And of course, depending on the target, one strain can perform better than the other. For example, Bovaria strain 1, it's better to control beetles in the fields because the strain 1 can produce metabolites, different metabolites that can control better beetles in the field when we compared with the strain 2, for example. And of course, each strain has its own particularities. It's like us. Each strain is like individuals, and individuals has its own peculiarities. And based on this all information, there is no unique solution when we are talking about formulation microorganisms. Each case is a specific case and requires a specific solution. And because of that, the selection of formulation components is extremely important, because the simple decision to change the concentration, to change the chemical composition of these components, to change the components itself, can create a huge impact in your biological active survival. And almost in the 100% of the time, the effect is negative. Differently from the chemical formulation, the simple decision to include or change anything in your formulation has a huge impact in your biological activity. And because of that, the selection part of your formulation development program, it's really, really important. And of course, when we're talking about, for example, for seed treatment formulations, we have to consider all those aspects that I presented before. But for seed treatment, we have to consider the seed space. Each seed allows us to apply a certain amount of liquid in its surface. And for example, for seed treatment products, you have to create a high concentrated product to be used in a low dosage. And remember, the biological product is part of a slurry. And in the slurry, we have the fungicides, we have insecticides, we have micronutrients, and the biological is part of that. And we have to use a really low dosage to allow us to include the biological in this package. And also, we have to consider the structure of our biological that we are considering to apply on seed. For example, here we can observe in the point of view, in the microbiology point of view, a big structure. And of course, when the seed starts its movement in the seed treatment unit, probably this structure will be lost in the seed treatment unit. And of course, the survival rate will decrease and your performance in the field will be affected. Also, we have to consider the compatibility between the agrochemicals, which is part of the slurry, and our biological ingredient. It's really important to test each slurry component separately, confirm the compatibility between these slurry components with your biological ingredients, but also it's important to test the compatibility of full slurry with your biological ingredients, because sometimes we find that the slurry components alone it's quite compatible, but when we put all these components together, the product of reaction between these components, that is what is harmful for your biological. And because of that, it's really important to study the compatibility of full slurry to confirm if the compatibility remains. And of course, we have to consider the seed treatment equipment. It's a lab treater equipment, it's an industrial treater, because different equipments can create a different effects in your biological survival. But Carlos, you show us what we have to considering during the formulation development program, but how we can evaluate these effects. In Croda today, we use three different capabilities. The first one is the microbiology labs, where we can use different methods to access the effects of formulation components in your biological ingredients. But also we have the formulation labs, and these two labs, they are working really, really close during these formulation development programs, because we have to guarantee that all the components are compatible, but of course we have to attend some characteristics to, for example, some physical chemical aspects of these formulations. And because of that, both labs are working really, really close during the formulation development step. And when the formulation was completely designed and all microbiology aspects and all physical chemical aspects was okay, then we move to plant biology facilities. And when we apply these formulations to check if these formulations is suitable to be applied on plants without any kind of negative impacts. And talk about a little bit about the methods we are using to check how the components can affect the microorganisms. In Croda today, we use two different microorganisms. One is Trichoderma, is a fungi biological ingredient, and Bradyrhizobium, that is a bacteria ingredient. Both of them, it's good as a microorganism model because they are able to respond really fast for any kinds of external factor, for example. And Bradyrhizobium, it's a bacteria gram-negative, which by nature is quite sensible for any of the external factors. And Trichoderma is as fungi, and Trichoderma is quite responsive to external factor as well. And to analyze the effects of components in these both microorganisms, today we are using colony forming units method. It's a basic in microbiology. Also, we are using a conidia germination method. This is specific for fungi ingredients. And also we have the conidia vigor method. In the next slides, I will explain a little bit the reasons behind we decided to include these tests in our studies. And of course, depending on the response we are looking for, we can help our partners to implement additional methods. So now I'm going to present you some results from these different methods and how we can analyze these results and how we can assure that this component is compatible with our biological ingredients or not. The first results I would like to present to you is the colony forming units. And here, analyzing 9 different options, 9 different chemical compositions, we start to observe some variations here. And in general, this kind of results show us that depending on the component composition, this component can affect your biological ingredient differently. But I would like to ask to all of you to pay attention in these two options here, 8 and 9. In the colony forming results point of view, these two options here, 8 and 9, was the best one because the colony number was quite stable over the time. So pay attention to these two options here. Another way that we can use the colony forming method to analyze the impacts of components in your biological survival is to analyze the purity of your components. And here we used the same dispersant, a regular dispersant, in the same dispersant but with a high purity grade. It's the same dispersants, the same chemical compositions used at the same concentration. And here we can observe the huge positive impact of purity in the colony counting here. So it's important during your screening studies to select the proper components for your formulation. It's important the chemical composition, but also the purity grades of this composition, because these two factors here can impact directly the survival of your formulation, of your biological ingredient. Here it's another method, but in this case here it's conidia viability. And using this method, we can observe now a really huge variations between the different compositions, but also over the time. And again, pay attention in these two options here. Of course, considering these variations, these two options here, 8 and 9, was the best one. And why? The idea here is to attenuate this natural drop that we observe in pure conidia. Naturally, the biological ingredients, they can present this natural drop. But when we are formulating this kind of ingredients, the main idea is to attenuate this natural drop. And we are able to get it using these two options here, 8 and 9. Okay. And here is another impact of the purity grade in the biological ingredient survival. And here, this attempt to attenuate the natural drop here, it's really clear. Again, we used the same dispersant here, a regular one, and the same dispersant with an improved purity grade. And here we can observe that using a high purity dispersant, we attenuated this natural drop in conidia viability. And attenuating this natural drop, we can improve the shelf life, we can improve the survival rate, and consequently, we can improve the performance in the field. And for example, using a regular dispersant, at the end of 180 days, we are able to get 26% of viable conidias. On the other hand, using the same dispersant with a high purity grade, we are able to find 54%. And this has a huge impact in the performance of the field. The higher is the percentage of viable conidias here, the best will be the performance in the field. And here it's an image to illustrate the effect of the high purity grade dispersants in the biological ingredient. In the picture A is the regular dispersant, and in picture B is the improved purity dispersant. The red arrows here is present the non-germinated conidias, and the green ones presented the germinated one. It's clear that the percentage of viable conidias here in a picture B is higher than the picture A. But the most important topic is this structure here. This structure here, the size of this structure is bigger than the structure observed in the picture A. This structure here in microbiology we call germinative tubes. And the size of the germinative tubes is directly linked with conidia vigor. And because of that, we decided to develop this software called Precision Bio. Precision Bio was completely developed in Croda, and using this software, we are able to create a number for conidia vigor. The conidia vigor method is not new. It's well described in the technical literature, but the way we are doing that, it's what is the innovation. We use a processing image to create a number and then generate a value for the vigor. And why we decided to create this software? During our studies, we observed that some products remain the colony counting quite stable over the time. Some products remain the percentage of viable conidias, of course, with some variations, stable over the time. But some products was affecting the size of this structure here. And because of that, we decided to create this number, to create this software to provide us this number. And after the image processing, this was the result. Here we can observe that different compositions here can impact directly the vigor of conidias. But Carlos, there's a lot of variations here. It's almost impossible to create to decide which component is better than other. Yes, this variation it's really normal because a seed conidia has different levels of maturity. And because of that, one conidia can germinate faster than others. And these variations is caused because of that. Do you remember the option 8 and 9 that we obtained the best results in colony method and viability method? Now take a look on that. Here, comparing with other components here, option 8 and 9 presents a not so good results. And I can prove it for you. Using a statistical analysis, we can, for example, calculate the integral of all curves obtained in this chart here, and then we can run a statistical test, for example, a Dunnett test. And then we can confirm that option 8 and 9, considering the vigor point of view, was not the best option. Okay, and this is how we can use the different methods to help us to decide with which product is better than other to be part of our biological formulation. These options, if we just considering the first two results, probably we could be face problems in the field because vigor is directly linked with the capacity of your biological ingredient to establish in the field. And consequently, if we delay this establishment in the field, with almost 100% of sure, the control, the performance of your product in the field, you'll be poor as well. So the more data, the more method we include during the screening step, the components screening step, the better will be our decision. And here is another interesting result. It's related to effect of biological dosage in a seed germination. This study was performed by one of our trainees, and to access this effect, we conditioning seeds in two different conditions. The first one was we kept the seeds for 10 minutes at 45 degrees, and in treatment 2, 5 minutes at 50 degrees. And what did this test show it to us? Sometimes it's not the intensity of external factor here represented by temperature, but the exposure period that is more harmful for our biological ingredients than the external factor here. What's the result means? When we take a look in the treatment 1 here, after between 20 days and 30 days after the biological seed application, we can observe a sharp decrease here in treatment 1 when compared with treatment 2. And this means that the exposure period was more harmful to biological ingredients than the intensity of external factor. And because of that, is really, really important to include a shelf life program in your formulation development studies, because sometimes the negative effects of or components or external factor will rise after a certain period of time. And if you include a shelf life program in your formulation development studies, you can observe this effect and of course avoid any future problem in the field. But also what we did, we also take these same seeds and then we tested the germination over the time. And we observed as the number of colony decreased over the time, the percentage of germinated seeds increased. This is a classic result of hypercolonization. Hypercolonization, it's when we apply a high amount of biological ingredients and then we affect negatively one aspect of plant, for example, in this case, the seed germination. And to reach the maximum germination here, observed after 60 days, the dosage of colonies per seed was around 10 to power 5. Because of that, it's also really, really important to include a dosage curve study in your formulation development program. Because if you apply a high amount, if you apply a high dosage of your biological products, in this case specific for seed treatment, you can affect negatively the germination of the seeds. This is a classic result of hypercolonization in the seeds. And in this case specific here, we applied trichoderma. And in nature, trichoderma is a saprophytic. They can decompose the vegetable material. And this is caused by trichoderma because of this nature. As a saprophytic, if you apply a high dosage, you can affect the seed germination. So take care with the dosage. It's not just because it's a biological product that you can use, for example, liters of biological products in seeds that we cannot face any kind of problem. That's not true. We have to include a dosage curve studies in our formulation development to avoid this kind of problem here in the field. So I present some results for you and how we can interpret the results to check to reach and to select the proper formulation components. But also we as a Croda, we can help you in provide you some delivery solutions ready to be used. And the first one is the solution for oil dispersion formulations. Oil dispersion formulations is widely used because the water activity in this kind of formulation is really low, and mainly for fungi ingredients. Fungi ingredients requires a really low water activity because in formulations with high water activities, the conidia can start to germinate, and then the shelf life of your product will decrease really drastically. Okay, and here we have three different solutions. And note, using the same concentration of biological ingredient here and changing the type of oil, we have to changing the surfactant package. Remember in the first slides, when we are talking to formulating biological activities, each case is a specific case and requires a specific solution. And because of that, changing the oil phase here, we have to changing the surfactant package. And of course, we have to test all these components separately. To know more about these chassis, you can scan here to get more information about that, or of course contact us from Croda anytime. And what's the benefits to use red chassis systems? In these chassis systems, we are using a pre-tested surfactant package, and this can save a lot of time in the lab because the people who work with formulation, we have to spend a lot of time in the lab. And using chassis systems pre-tested, we can reduce your development time, and of course we can save money. We can reduce the costs of your formulation development program. Also, we can provide you the recipe and the methods to prepare this formulation. And of course, you can count with the Croda support during the formulation development. And also, this kind of formulation can be used with chemical active ingredients. Another solution that it's available, it's the Atrox BS50. This product was recently launched in the market, and this formulation, it's a ready-to-use solution for solid formulations. And this solution here allow us to include a really high biological ingredient concentration here. And one of the biggest benefits to use Atrox BS50 is regarding the wettability. Fungi activity ingredient by nature is quite hydrophobic, and high hydrophobicity creates a poor wettability and a poor suspensibility. And wettability and suspensibility is directly linked with distribution. And a product with a poor wettability and a poor suspensibility means a poor distribution. And poor distribution means bad performance in the field. And to solve this problem, we developed the Atrox BS50, and even with a high concentration here of biological ingredient, we were able to improve the wettability and consequently improve the suspensibility. And improving these two physical chemical aspects in your formulation, you can reach a really amazing performance in the field. And what is the benefits of Atrox BS50? Atrox BS50 is a complete delivery system, is ready to use for solid formulations. We can shortening the development period because this formulation, this chassis, is easy to be used and easy to be formulated. The composition was optimized to deliver the best performance in the field. It's easy to be used, is easy to be formulated, and the composition was designed to deliver the best performance in the field. Also, using the Atrox BS50, we can improve the wetting upon dilution in the spray tank, even with biological ingredients with high hydrophobicity. Hydrophobicity creates a poor distribution, poor suspensibility, and consequently, you can face problems in the field. Of course, using the Atrox BS50, we can reach a good suspensibility, and of course, formulations with good suspensibility can create a good performance in the field. Maintains the viability of spores over the time and is suitable for seed application. And guys, to summarize all of the topics that we covered during this presentation, I would like to highlight some points, and always keep in mind these points during your formulation development program. The first, the selection of a formulation component, it's really important. You have to consider the chemical composition, the purity level. You have to consider the concentration you are using in your formulation. You have to include a shelf life study. You have to include a dosage curve studies, because all this information will help you to decide which option is better for your biological ingredients. The more data we collected, the better will be your formulation. And here I would like to share a bad experience that I have. Sometimes we considering all these steps that I present for all of you, but we forget an important part of the formulation, that is the package. We always forget the package. A couple years ago, I lost a big experiment, a big test here, because I was using a package that the plastic which this bottle was made contained a biocide in the plastic composition, and this biocide was flowing through from the plastic bottle to the formulation, and this biocide was killing all the biological ingredients. The survival of this biological ingredient was dropping really sharply over the time. And then I find that the problem was not the components that I was testing at the time, but the package. So guys, include a study of the package. Avoid package with biocides in its composition. This is really important because the biocide in the composition, in the plastic composition, can affect negatively the shelf life of your product. Also, know your biological active. Remember, if you know deeper if you have a deeper knowledge about your biological ingredient, this can give you the chance to create a differentiation for your products in the market. Remember, this market is really fragmented, and any kind of differentiations you are able to create will be excellent for you. Again, there is no unique solution when we are talking about formulation microorganisms. Each case is a specific case and requires a specific solution. Of course, include package options in your development program. Include different packages, include different chassis during your development program, because using this kind of package with a little adjustment, you can design a really good formulation for your biological ingredients. And the most important, the collaboration is the key to success. For biological market, the collaboration is the key to success. And think on that. If you register in our website, in the Croda Crop Care website, you can have access to all of the latest product launches. You can have access to exclusive content. You can order samples for any of our solutions. You can get informations about how Croda can help you to develop a different kind of formulation. You can receive exclusive invites, and of course, be updated for all of our development in this area. And to finalize, I would like to say thank you for your attention. For me, it was an honor to share a little bit about my experience, and of course, say thank you for the organizers. And now we have some time to answer some questions. Thank you.
Thanks, Carlos. Brian, do you want
Hello.
to say anything before we move on to the Q&A, or should we make a start on the Q&A?
Okay.
Yeah, okay, so we'll start making our way through the questions then. So hi everybody, I'm Claire Hunt, Marketing Manager at Croda, and I'm just going to coordinate reading out the questions for Carlos. Okay, so we're just going to make our way through the list. As Brian said, if we don't get through them all, if you've opted into the poll that you should see on your screen, we will be able to provide answers afterwards. So it is important that you click yes if you want an answer to your question. So first one, how long is the ideal shelf life for biopesticides, and what are the most important factors that affect shelf lives of microbes?
Yeah, this is a good question. Actually, we don't have a standard time for shelf life, specific for biological products. Actually, what is determine the shelf life is the characteristics of your biological ingredient, and of course, your formulation design. the different biological ingredients has different kind of shelf life. For example, if we are talking about, for example, a gram-negative bacteria like Bradyrhizobium, the shelf life of this bacteria is really, really low. It's really, really short. But this is caused because of the natural characteristics of your biological ingredient. There is no a good period of your of shelf life, for example, and the factors that can impact the shelf life period is of course the formulation. If you select properly your formulation components, you can avoid these problems, of course. But the environmental factors, usually the biological products must be stored in a specific conditions. And if you take these products out from these specific conditions, probably the shelf life will decrease really drastically. This is, of course, there's a lot of aspects that we have to consider, but the main two is the formulation and the natural characteristics of your biological ingredients.
Thanks, Carlos. Next one, will ODs be compatible with those seed treating machines which are usually used for water dispersions?
Yeah, this is a good question as well. Oil formulations for seed treatment can be a little bit tricky because seed treatment, all the products that we apply in the seed treatment, they need to have the characteristics to be dried really fast. And when we include oil dispersion into the system, these important characteristics of seed treatment can be drastically affected. For seed treatment, oil formulation is not a good option because we can affect, for example, the seed dry capacity. We can impact negatively the seed coat quality, and for seed treatment market, cosmetic aspect, it's really important. The farmers love a seed with shining effect, with a high color intensity, and sometimes use oil formulation into the system could be a huge problem. For seed treatment, we have another options, but oil formulation is not so a good option for this application. Yeah.
Next one, I think I'm going to read this correctly. How can I evaluate the hydrophobicity of a microorganism? Have we got any advice there?
Yes, this is a good question. I'm not sure if we have a standardized methods to analyze this aspect. What we can do is trying to check it, but it's visually. I have to check if you, at least here in Latin, we have some specific test for that. But one way to do that is use a wettability test. It's a standardized test. And then, if I'm correct, we can use in a water hardness predetermined, and then include a certain amount of your biological activity and keep its moving, and then check in a certain period of time how many of these biological ingredients was able to be wetted. I know that the CPAC and CPAC has a standardized test to do that, but it's related to wettability, it's not related to hydrophobicity level. Okay.
Our formulation knowledge on biologicals is pretty new, and we don't have a lot of equipment yet. Is Croda open to working together with customers on specific biological formulations?
Sure, definitely. Yeah. As a Croda, we love to work in partnership with our customers, because as Claire mentioned, and during my presentation, I mentioned it as well. During the formulation development program, the more data you are able to collect, the best will be your formulation. And we as a Croda, we are fully open to help you during this step in your formulation development program. Feel free to contact us anytime check the possibilities, and we are more than happy to help you in this step.
Yeah, certainly. We can, if you've clicked yes to the poll, we'll be able to get in touch with you. If not, if you know Croda, please get in touch with your local sales team. If not, you can email cropcare@croda.com and we'll get back to you. So that's cropcare@croda.com. So anybody that would like to get in touch with us afterwards, please feel free to email and we'll get back to you. Brian, do we have time for one more, or are we done?
Yeah, we have one more time for one more question. I do just want to let everyone know that the next ISAA symposium will take place in 2025. Country and city will be announced the week of November 6th. So looking forward to seeing everyone there.
Okay, I'll pick one more from the many that have come in. Let's take. What do you mean by high purity dispersants? Are they byproducts, unreacted starter materials? What do we mean by that?
Yeah. During the dispersant production, sometimes we have to use some chemical reactions, and sometimes it's not the component itself, but the products of this reaction that remains in the dispersant formulation, that which can be harmful for the biological ingredients. And the high purity dispersant is a dispersant which pass through a processes to take these impurities out and then improve the purity grade. And as I presented during my presentation, the purity level of any component has a huge impact in the survival rate of your biological. And because of that, it's really important to consider the chemical composition of all of these components and also the purity level, because these two factors will impact directly your biological ingredients.
Thank you, Carlos. Brian, do we need to end there? I am aware we're at time, and I'm conscious that there are many questions that we have not got round to answering. But as we said, we will get round to answering them and circulating those afterwards.
Yeah, great. Thank you. We'll be sure to put those together. Please opt in if you want to receive that content, and have a great day, everyone.
Yeah, thanks everyone. Thanks, Carlos.
Thank you for your attention. Bye-bye.